this is like a Mythbusters segment, okay? There's a common misconception that people have once you learn that like, if I push on something with a given force, it pushes back on me with the same force. People often say, well then obviously, here's a person standing on the floor. The normal force and gravity form one of these forced pairs, equal and opposite. It's not true. Not true, okay? Gravitational force and the normal force are not a forced pair. The gravitational force that's pulling down on the person, the forced pair for that is actually the Earth. That person's pulling on the Earth as well. So the gravitational force of you on the Earth is the same as the gravitational force of the Earth on you. The normal force, this is how much you're pushing down on the floor compared to how much the floor is pushing back on you. It might sound like I'm saying the same thing both times, but I'm not. What if this person, the floor that they're standing on, is actually in an elevator? So if we're in an elevator and the elevator starts to accelerate downward with an acceleration of 5 meters per second squared, okay? Now, the acceleration of this person is 5 meters per second squared down. Gravity is pulling them down. The acceleration from gravity would be 9.8 meters per second squared. This is about half of gravity. So what this means is if the person's accelerating downward at 5 meters per second squared, we know that gravity's pulling them down at 9.8. That means the floor is pushing back at 4.8 meters per second squared. So the force of the floor on the person is whatever the person's mass is times 4.8 meters per second squared. So in this case, you can see the force of gravity on the person is still 9.8 times their mass, but the normal force of the floor is now only 4.8 times their mass. They're not equal and opposite. They're only the same if you're not accelerating in this direction.